For example 1, we're going to graph the absolute value of x is less than 12. So previously you guys were just graphing x is less than 12, right? Now they put an absolute value on it. So it's going to work very similar to the way it works whenever we are solving our absolute value equations. Just instead of an equal sign, it has that less than or greater than, or less than or equal to, greater than or equal to, okay? So whenever we are solving an absolute value equation, right, it's kind of the same as the inequality in that we said if you have the absolute value equals a number, we can expect to have how many solutions? 2, right? Same thing is true here. Turn around. So we've got that our first inequality will be exactly as it's written, just like it was for our equations, okay? And for your second one, we're going to make the 12 negative, but we also flip the inequality as well. So now it would be x is greater than negative 12. Okay? So I'm going to go and graph both of these inequalities over here on the number line. So over here at positive 12, is my point open or closed? Open, good. And we said that x was less than 12, meaning that it's headed which way? Left. To the left. Okay, so it's going to be headed this way. All right. And then over here at negative 12, again, I'm going to have an open point, right? And which direction is this one headed? To the right. So what do you guys notice about our two solutions? Right, they intersect, they overlap. So our solution is all of the stuff really from here to here, right? It's the stuff they share, right? Okay. So whenever they overlap like that, whenever that's what we're looking for, this is one of those that we call the and statement, okay? And previously you would write your solutions in both set and interval notation, right? So for my interval notation, we would say it starts at negative 12 and goes to 12. So both would require me to use parentheses since we said they were open. Today, if you scroll down, you can see that they actually ask for it in interval and inequality notation instead of set notation. Inequality notation is the same thing as set notation, just without the fancy brackets. So it's just the inequality part you would set up after you drew that line, okay? So the way that would look is that we said, again, it went from negative 12 to 12. So this would be interval, and this would be inequality notation right here. All right. Okay, let's do another example. So for example 2, my first inequality, I keep everything exactly as is, right? So I'm going to have 7x is greater than or equal to 21. Okay, and then I also need to set up the other, which means that I keep the 7x, the part inside the absolute value, the same. But what I change is the other side, right? I change its sign, and I'm going to flip the inequality as well. So now it'll be 7x is less than or equal to negative 21, okay? All right, now these ones do require us to do a little solving because there was something inside of that absolute value. So what would I do now? Divide by 7. Good. So when I divide 21 by 7, I'm going to get that x is greater than or equal to 3. And when I divide negative 21 by 7, I'm going to have x is less than or equal to negative 3. Good. Okay. All right, so if I were to go and graph these, Whether I graph them when they were here or here, they should look pretty similar. Right here, I'm going to have something at negative 21 and positive 21. Here, I've got points at negative 3 and positive 3, right? But the inequalities still point the same direction, right? They're just simplified values of each other. So this time, my inequality had the equal to, so all of my points will be solid points, right? Okay, and looking at these two here, right, whenever we had our 21 and our 3, x was greater than those, right? So which direction is that headed? Okay, so both of these would be headed this way. Okay, and then for my negative solutions that we found, negative 21, negative 3, x was less than those values, right? So from our negative values, we were headed to the left. So these don't have an intersection, right? These don't overlap. So this is not one of those and scenarios. This is an or, right? So these would literally be the inequality notation, right? And then the interval notation for this part would be that it goes from 3 to infinity, right? And this part goes from negative infinity to negative 3, right? All right, and we got one more in this section. So I'm going to do the same thing.
Would it have the square brackets for the negative 3?
Oh, yes, they should. Thank you, because they were solid points. Thank you for catching that. So for example number 3, remember my first one will be exactly as it's written. I'm just going to drop the absolute value bars. Oops, that was a 3, not a 7. So I've got 5x plus 3 is less than 7. Okay, and then what should the other inequality be? Perfect. Okay, and then we should do a little bit of solving, right? So what do I do to solve? Subtract 3, good. So here I'd have 5x is less than 4, and here I'd have 5x is greater than negative 10. Nice. Okay, after we've subtracted, what should we do next? Divide, So here I would have x is less than 4/5, very good. And then over here, I'm going to have x is greater than negative 2. Okay, so let's go put these on the number line. So I'm going to have something over here at 4/5 and something over here at negative 2. Are my points for this one open or closed? Open. Okay. From 4/5, am I going to the left or to the right? To the left, And from negative 2, am I going to the left or to the right? To the right. So this time, they overlap again, right? So this would be one of those and scenarios, right? They share a portion of the line. So my interval notation, when it asks for interval notation, this is the parenthesis bracket one. We would say that it started at, right, and goes to 4/5, right? And we would use parentheses for those since they were open. Okay. Now your inequality notation, remember this is the same as set notation, just after the fancy bracket X with the line, right? Just the inequality part. Okay. So kind of the same scenario, right? We're saying it started at -2 and it goes to 4/5 and x is everything in between. Okay. So, looking at the 3 examples we just did, do you guys notice a pattern so that we might be able to predict if it's going to be an and or an or before we ever start? What would that pattern be?
If the x is less than the number it's and it's greater than x.
Perfect. So she said when it's this symbol, right, when the absolute value is less than, with the x inside of there, then it ended up being an and. And when it was flipped the opposite direction, it was an or. So if it's flipped this way, we know we have and, right? And when it's flipped this way, we know we are dealing with an or statement. Okay? And when it's an and statement, we know that our answers are going to look something like this, right? When it's an or statement, we have 2 separate inequalities that we have to write. Okay, so we can go ahead and anticipate what our answers will look like. Now, since they just said A, we don't really know what A is, but -A is less than whatever our function is less than A, right, is how it would look for those and statements. And then like you guys were saying, 2 separate for our or statements. So it will be greater than A or less than -A. So based on which way your inequality faces, you can already predict if it's an and or an or, which means you also should already be anticipating what your answer should look like. Okay? That way you'll also know if you solved it correctly or not, right? Same rules apply when it's the less than or equal to, greater than or equal to. So the direction would be what matters. Okay, so keeping that in mind, looking at example 4, what type is this? Which one is it? The or. Okay. So we already know that that means we should end up with 2 separate inequalities, meaning on our number line they should be going separate ways, right? Okay, so let's solve it and see if that's the case. So for my first one, remember we keep it the same, right? So I'm going to have 2x over 7 plus 9 is greater than 5 over 7. And then for the other one, I'm going to have 2x over 7 plus 9 is less than -5 over 7. Nice. All right. Okay, and now we need to solve. So what am I going to do first? Okay, so I'm going to subtract 9 from both sides. If you don't have a calculator on you and you are trying to do these type of problems, you could get rid of your fractions first, right? How would I get rid of all the fractions here? I could multiply everything by 7, and that would fix that problem for us, right? So here, your 7s would cross out. You'd just be left with 2x, right? What about 7 times 9? What's that?
63.
So I'd have plus 63 is greater than, and then your 7s would cross out here as well, right? So 5. Then same thing over here. 7s cross out. We got 2x, like you guys said. 7 times 9 is 63. And then our 7s cross out, so less than -5, right? So if you're ever without a calculator trying to solve these, that's a good way to get rid of your fractions. Okay, so I would want to move 63 over. What is 5 minus 63? -58. So I got 2x is greater than -58. And then I divide by 2, and I get that x is greater than... Good. All right. For the other inequality, we have to subtract 63 from -5, which would give us Good. And again, I'll divide by 2, and I end up with x is less than, yes, negative 34. So let's go put those on the number line. So over here, I'm at negative 34. Over here, I'm at negative 29. Are those points open or closed? Open. Okay. From negative 29, which direction am I headed? To the right. And from negative 34 to the left. So just like we anticipated, going two separate ways because we said this was an or statement, right? So our solution was those two inequalities going separate directions. Good. Okay. So now that we kind of understand the setup for inequalities versus just those equations from the last couple days, flip it over onto the back. And we're going to look at some that might have something outside of those absolute values on the same side of the equation. Okay, now remember we had 4 steps for solving equations, right? Those 4 steps translate over to what we are doing now. What was step number 1? Isolate. Yes, good. So that is still our step number 1. Isolate the absolute value. Typically should be on the left side of the equation, right? Okay? All right, and then what was step number 2 for solving the equations? Right, so to get rid of the absolute value bars so we can make 2 equations. Okay, so drop the absolute value bars and write 2 equations. Now for us today, we're going to be writing inequalities instead of equations. Okay. Now for the equations, all we had to do was change the signs of the right side, right? Because it was just a normal equal sign. But today, when we're dealing with inequalities, not only am I going to change the signs of the right side, I also have to flip the inequality, right? So for the first one, remember you're going to keep it exactly as is. So you're going to keep the sign and keep the number the same value. Okay? But for the second one, you're going to flip your inequality or flip your sign and take the opposite of the number. So change its sign. If it was positive, we make it negative. If it was negative, we're going to make it positive. Okay? And then once we had our 2 equations set up, what did we do next? Solve. Right. So same for our inequalities. So next we will solve. Now for our inequalities, after we solve, we also graph them, right? So we are going to solve and graph on step number 3. And then what was step number 4? To check, right. But this is a little bit different, right? Because previously it had to equal a specific number, right? Here we're saying it should be something greater than that number or less than that number, right? So when we go to check, what we're actually going to check is you will check one number that falls in each region of our graph. All right, so let's take a look at what that could be. So, number 5, according to step number 1, what are we doing first? Isolating. So what am I moving? The 2. Good. So I'm going to subtract 2. And now we got the absolute value of negative 5x plus 8 is less than 23, right? Okay, so step number 1, check. We isolated it. what do I do now? Make the two equations, right. Okay, now remember the first equation, so there was step number 1. Here we're on step number 2. Should look exactly the same, right? Negative 5x plus 8 is less than 23. Okay, my second equation is going to be negative 5x plus 8 is greater than negative 23. All right. And based on the direction that our inequality faced, is this an and or an or? And. Good. So we're already anticipating what this will look like on the number line. Okay? So step number 2, check. Step number 3 is to solve and graph. So what are we going to do first to solve? Subtract 8. What is 23 minus 8? What is it? 15, okay. And over here, negative 23 minus 8 would be, okay. All right, and then we just need to divide, right? Okay. So I'm dividing by a negative 5. What happens whenever I divide by a negative? We flip the inequality. Good. So this is going to actually become x is greater than negative 3, right? And this one will now be x is less than negative 31. Or sorry, I guess it becomes positive because there was 2 negatives. Then 31 over 5, right? Okay. So now that we actually have our numbers, we can go put those on the number line. If you're not exactly sure where 31 over 5 falls on the number line, feel free to convert that to a decimal if you were trying to put it between something. Approximately, what is that as a decimal? 6.2. So this is the same as 6.2. Okay, so I'm going to come over here to my number line. I got something at negative 3. And I've got something over here at 6.2. Are they open or closed points? Open. Okay. And we said this was an and statement. So and means they should overlap, right? Okay, well, from negative 3, I am headed to the right. Okay. And from 6.2, I'm headed to the left. So sure enough, we are going to have overlap, right? They are going to intersect in between negative 3 and 6.2. Okay? All right. Then step number 4 is to check one number inside of each region. Okay? So your 3 regions would be over here, here in the middle, and over here on this end. So I'll call this regions 1, 2, and 3. You can pick any number that would fall in that region to check with, okay? So I'm going to draw a little line here, and we'll do all our checks over here. So what would be a number that falls in region 1? Negative 4. Perfect. So that's what I'm going to go check in the original, okay? So I'll have the absolute value of negative 5 times negative 4 plus 8, close that absolute value, plus 2 is less than 25. All right, so remember we treat those absolute values kind of like parentheses. So inside of there, we got negative 5 times negative 4, which is 20, plus 8, which is 28. And what's the absolute value of 28? 28. So this is just 28 plus 2 is less than 25. Is that true? No. Which makes sense because we said that's not part of our solution, right? So that part should be false. Okay? Now let's pick a number in region 2. What would be a number that falls in region 2?
1.
Yeah, any of those. All right. I would pick something like 1. Makes it easier for you when you're doing the math. So we'd have negative 5 times 1 plus 8 plus 2 is less than 25. Well, what is negative 5 times 1? And what's negative 5 plus 8? 3. And what's the absolute value of 3? 3. So this is 3 plus 2 is less than 25. Is that true?
Yes.
Which makes sense because we did say that that section was our solution, right? Okay, and then you can pick something in that third region. What's something that would fall in the third region? 7, okay. So negative 5 times 7 plus 8 plus 2 is less than 25. Well, negative 5 times 7 is negative 35. Negative 35 plus 8 would be, and what's the absolute value of negative 27? Okay, so this just became 27 plus 2 is less than 25. Is that true? No. Which again makes sense because we said that this part and this part were not part of our solution, right? Okay? So, we agree that this part right here is our solution. We are going to write our solution in both interval and set notation. So we'll do interval first. It goes from where to where, did we say? Okay. So we're going to say from negative 3 to 31 over 5. And we will use parentheses, right? Okay. And then for our set notation, we'll have x. Very good. So set and inequality are the same thing. They'll ask you for both of them interchangeably. If they just wanted inequality, you would only write that inequality part. So we would just have negative 3 is less than x is less than 31 over 5.
They would tell you which one.
They'll tell you. If it's on a test or something like that, they're going to tell you, write it in this specific form. All right.